8th grade math, test 15, study guide. Problem number 1 says find the range for the value of this expression. What we do is we simplify this first. So we go 45 plus 2, take away 20, which you should have got 27. You can use the rule for subtraction in teams there. Square root of 27, well, that's in between these two perfect squares, these two consecutive right next to each other perfect squares. 5 times 5 is 25, 6 times 6 is 36. It's in the middle of those two. So it's in between 5 and 6, so it's 5 point something. And there's only one range that could have worked. The answer already has to be B, but sometimes the question is round to the nearest tenth, so we'll continue how would we do this problem. So I see that 27 is closer to 25 than it is at 36. So it's on the closer end, like 5.1, 5.2, maybe 5.3. If it was about in the middle of these two, I'd say it's maybe 5.4, 5.5, 5.6. If it was closer to this one over here, it could be 5.7, 5.8, 5.9. So the answer for this one has to be B, 5.1 and 5.3. That's the range that does in between. So we take number 2 now, and number 2 says give the values for the numeric expressions. So 6 over 10, if you read that, that's 6/10. So that's another way to write 6/10. Or you could divide in and out. You get 0.6 either way. Now, we memorized the square root of 625. We said that's 25, because 25 times 25 is 625. So the square root of 625 is 25. Now, 25 over 100, again, if you read it, that says 25 hundredths. So no need to divide, just write 25 hundredths as a decimal. And then the last one, pi over 2 means pi divided by 2. And pi is about 3.14, so that's like saying 3.14 divided by 2. If you go in and out here, remember to put your decimal up top, you get 1 and 57 hundredths. So those are the estimated values for those expressions. Number 3 says a container holds 3 2/10 grains of sand. There are 3 and, excuse me, I think I read that incorrectly. A container holds 3 to the 2nd power grains of sand, or 3 squared grains of sand. And then it says that there are 3 to the 10th power grains of sand at a beach. How many containers do you need to store all that sand? Well, what we're doing there is dividing. We're taking the bigger number and dividing the bottom, put that on bottom. And when I'm dividing powers to the same base, I copy the base, subtract the exponent. So it's 3 to the 8th power containers. Number 4, we're going to have to simplify all those that first expression, and then simplify all the answers to see which one it's closer to. So the first expression, we're going to go inside the parentheses first. This isn't the only way to do it. I just think it's the easiest. Go inside first. So that's where I'm multiplying powers with the same base. So I copy the base and add the exponents. Well, using teams, I see there are more positives than negatives. That's why it's positive 1, not negative 1. And now I'll do to the 3rd power. 3 to the 1st to the 3rd power. This is where I copy the base and multiply the exponents. So this is where I add them. But then when I have power next to power, that's when I multiply them. So 3 to the 3rd power is the answer for that one. Okay. But I have to figure out which of these expressions are the same as 3 to the 3rd power. So the first one, expression 1, says you got 3 to the 7th times 2 to the 16th. Copy the base, add the exponents. Well, that doesn't equal 3 to the 3rd. Expression 2, you have 3 to the 10th divided by 3 to the 7th. Well, I copy the base. Again, like I said earlier, that's where I subtract the exponents. That does equal 3 to the 3rd power. So that's one of our answers. And example 3, what I'm going to do is I'm going to simplify the top part first. So I'm going to go 3 to the 2nd times 3 to the negative 3rd. Again, when you're multiplying powers with the same base like we did here and inside here, I copy the base and add the 2 exponents. This time there's more negatives than positives, so that's negative 1. Now I'm going to divide, so I copy the base and subtract the 2 exponents. I go 3 to the negative 1 minus 3 power, because there's a 3 on bottom. I can do the rule for subtraction. And teams there. Opposite teams means subtract, so I got 3 to the negative 4th. That's not the same as 3 to the 3rd. And then the last one, 27. Well, if I took 3 to the 3rd and I go 3 times 3, which is 9, times another 3, which is 27, I see that example 4 is the same. Expression 4 is the same. So the answer is 2 and 4. Number 5, they gave us this multiplication problem involving scientific notation. So what I do then is I take my two coefficients, the two numbers in front, and I multiply those two. So I go over here, 2.2 times 7. You should get 15 and 4/10. And then when I multiply my tens, that's just copying the base and adding the exponents like we did on those previous problems. So I copy those two and add 8 plus 4 to get 12. However, this is not in scientific notation yet. So this is where that lesson where we drew 3 arrows. So I'm going to take my coefficient and rewrite it. But this time I'm going to write it in scientific notation, which means the decimal has to go to the right of the first number that's not 0. So I have to move it one time. So another way to say 15 and 4/10 is 1.54 times 10, or 10 to the first. Because if I multiply this times this, I get the same number. So that's the same thing. The other one I just dropped down. So again, I have to simplify this by multiplying powers with the same base, copy the base and add the exponents. And this times this is this number right here. Number 6 says, find the value of x. In other words, solve. In other words, isolate the variable for this equation. So I'm going to do the rule for subtraction first, right? When I have subtraction, I draw two sticks to add the opposite. Now I'm going to combine like terms. I got 10x and 3 more x's, that equals 13x's. Remember, we don't do inverse operations, right? If it says 3x, I don't subtract 3x from 10x. I just treat it the way it is. Why? Because they're already on the same side, right? So now I can isolate the variable. This is where I do opposite operations. Right? So if they're not on the same side, in other words, I have to start moving stuff to isolate the x. If it says positive x, I do the opposite. I subtract x. If it says times 13, I divide by 13. Right? So when I'm simplifying, I don't do inverse operations, but when I'm isolating, I do. And when you have 52 divided by 13, you should get 4. Solution is 4. Number 7 says, pick all the equations that have infinitely many solutions. Well, infinitely many solutions means this. After you simplify both sides, then you're going to get the same coefficient and the same constant. If that's true, you have an infinitely many solution. Okay, you have infinitely many solutions, I should say. All right, so let's take a look at these problems. Equation number 1. We're going to simplify both sides first. Simplify means distribute and then combine like terms. Well, I distributed. There are no like terms to combine, and I can stop right there. I don't actually have to solve this to see how many solutions there are. I can stop. Once both sides are simplified, I look at the coefficient. The number in front of x's are different. So I know automatically there's one solution. Whenever these are different, there's one solution. In other words, there's going to be an answer. It's not one of those weird special cases. So let's go to number 2 now. Number 2 says, this long equation here, we're going to, again, distribute and combine like terms. But before we do, we're going to do the rule for subtraction, right? I didn't do that up here because that side was already simplified. But if I'm going to simplify, I definitely want to do rule for subtraction. So for minus 4, I put plus negative 4. Over here, you see where it says minus and then parentheses? Well, you have to distribute a negative 1 there. That's what that means. So I do that. I go 3 times x is 3x. 3 times 3 is 9. Everything else I copy. Over here, when I distribute a negative 1, negative 1 times 10 is negative 10. And negative 1 times negative x is positive x. So I distributed this negative right here. This times this. And this times this is what I did in this line. Okay, so now I'm going to combine like terms. I already did the rule for subtraction, so I can use teams. 3x plus 9 plus negative 4. Well, I'm going to combine the constants, right? The numbers with no letters next to them. I go 9 plus negative 4. I use teams, which is 5. Over here, 2x and x is 3x plus negative 10. Both sides are simplified. I don't have to keep solving this. I can just take a look at my rules and see if there's one solution, infinitely many, or no solutions. And if I look and see that my coefficients are the same, then it's one of two choices, right? Up here, my coefficients were different. That means one answer. Down here, coefficients are the same. You have two choices. Either it's no solution or infinitely many. Since my constants are different, this is no solution. In other words, there's no x you can put in there to make this true. So the answer is there is no answer. But remember, we're looking for infinitely many. So far, 1 and 2 didn't work. So for equation 3, we do the same thing. We do the rule for subtraction. Add the opposite right here. And as always, pause this video if you need time to get caught up. You can always pause and rewind. So, and then, like we said before, we distribute here. Over here, we're already ready to combine like terms. 11 plus negative 8 is 3. Over here, 3 times x plus 1 is 3x plus 3. Remember, you have to go 3 times x to get 3x, and 3 times 1 to get 3. So we distribute. Now we can combine like terms on the right side. Negative x and 3x, well, that's negative 1 plus 3, which is 2. So I can stop there. Once both sides are simplified, I stop. I look at my coefficients. Are they the same? If the answer is yes, then it's either no solution or infinitely many. So I have to look at another thing to make that decision. I look at the constant. So I look at the number. This is positive 3, this is positive 3 also. When they're both the same on both sides, that's infinitely many. That means it doesn't matter what number I pick. Right? That was that magic trick I showed you guys in class in that lesson. So any number will be a solution. Any number that I put here, here, and here, both sides will always be the same. All right. Example 4, rule for subtraction. Right here I did add the opposite. Right here I did add the opposite also. And when we have parentheses within parentheses, we make the parentheses outside parentheses bracket, correct? Now we distribute. So I go 2 times 8x is 16x. 2 times negative 4 is negative 8. Copy the rest. Over here, 2 times 3, negative 2 times 3 is negative 6. And negative 2 times negative 8. Negative times negative is positive. That's positive 16. I'm not simplified yet, though, because after I distribute, I combine like terms if I can. On the left side, I can. On the left side, I have negative 8 and 2. That combines to be equal negative 6. Both sides are simplified. So, look at your coefficients. Are they the same? If they are, then it's not one solution. It's one of those special cases. Now look at the constant. Are they the same? If they are, it's infinitely many. If they're not, it's no solution. So, equations 3 and 4 had no solutions. Number 8, the directions say, for each equation, if you place the 3 in the first box and then a 3 in the second box, how many solutions would you have for this equation? So what we're going to do, like we did before, is we're going to simplify first. In this left side, we need to simplify. There's nothing to distribute because there aren't even any parentheses, right? So I go 10x, take away 5x. Well, I can do the rule for subtraction there. I can do the rule for subtraction here, right? Add the opposite, draw 2 sticks. And I have 10x's and negative 5x's and negative 2x's. If I use teams there, I get a total of 3x's. And then there's a positive 3. Okay, now on the right side, all I did is copied it. So now this is what the question said. They said, if you put a 3 right here, and you put a 3 right here, how many solutions are there? Well, if you look at that, they're the same thing on both sides. That's infinitely many solutions. Okay, so we just plug it in at that point. All right. Number 9 says this. Which graph below has the same slope, which table below has the same slope as the graph? So, the graph, you can take any 2 points that are on the lattices, right? And we can rise up 2 and run 3. Here's a slope of 2/3. You could also take 2 points and do the slope formula, right? Y minus y over x minus x. Okay, so that's what we're going to do for table A. Table A, we're going to look at the slope. So I'll take 2 points. 3, 2, and 0, 0. 3, 2, and 0, 0. I go y minus y, or 2 take away 0 is 2. X minus x, 3 take away nothing is 3. The slope is 2/3. Okay, that's the same. Now, you could also done this. If you know this is a line, in other words, if I ask you to find slope, you know it's a line, right? And you see it goes through 0, 0, you also know it's proportional. You could have just put 2 over 3, 2/3 that way, and reduce, right, to get your slope. All right, the other ones won't work, as you can see here. So for B, we have that table, and I just took 2 points. I took the points 210 and 420. I only need to use 2 of those points. So I go here, 210 and 420. I can go y minus y, but actually I can start on the right side if I want to avoid negatives. I can go right minus left, which is I did, as long as I go right minus left on the bottom also. So I did that this time to try to avoid negatives, and I get a slope of 5. So that didn't work. C, as you can see, will not work, because if I go y minus y over x minus x, I'm going to get a slope of 2. And D won't work either, because if I go, let me see, I'll go on the right side this time first to avoid negatives. So I'll go 13, take away 7 on top, and on the bottom, I have to start on the right side also if I do that. 4 take away 2 is 2, so that's a slope of 3. The only one that worked is A. Alright, so 10 says, below is a graph. You're not you're not given the equation for this graph, so you're not going to write the equation. Alright, so we're going to use this graph though. So now I go down here and read the directions. Directions say, pick the equation below that has the greater rate of change than the above. So first of all, we have to find this rate of change, or in other words, we got to find this slope, right? I'll take 2 points. Here's a point, here's a point. So I rise up 1, 2, 3, and run 1. That has a slope of 3. I rose 3 and I ran 1. The line has a slope of 3. So now I got to look at the slopes for all these equations down here. So the first one, it has an equation that's in slope-intercept form. The y is isolated. I see the slope is 3. That's the same. We want, the direction said, which one has a greater rate of change, or a bigger absolute value, right? So the next one, B, was written like this. Let's convert that and put that in slope-intercept form. We learned in class a couple times that x over 4 is the same as 1/4 x, so the slope is 1/4. That's smaller. We want greater. C, it's already in slope-intercept form. The coefficient is 4. This has a slope of 4. Well, 4 has a greater absolute value than 3, so that's a steeper or a greater slope. And D wouldn't work because, again, I convert this slope-intercept form. 1/2 is not steeper than 3. Alright, so number 11, we have an equation, and they say which ordered pairs below are solutions. So that means this. If I were to take these here, here's the first one, number 1, and plug it in, then do I get a true equation? So this is x and this is y. So I put the x where the x goes and the y where the y goes. And this is the first step to check to see if this point is a solution to this equation. So I plug in x here and y here, and then I simplify. 1/2 of -2 is -1. -1 minus 3 is -4. 4 does not equal -4, so that's not a solution for that. In other words, that's not on that line. Number 2, here's my equation. Again, going to plug it in there. Going to put the y where the y goes, and the x where the x goes, and simplify. On the right side, 1/2 of 2 is 1. 1 take away 3 is -3. -2 doesn't equal -3. That's not a... Whoa, hold on now. Whoa, Nelly. I wrote this incorrectly. Sorry about that. 1 plus -3 is -2. I don't know why I wrote that incorrectly. Which is a solution. So number 2 did work. Alright, now number 3. Let's check out number 3. I have that point 0, -3. I plug it in. Y goes here, x goes here. Well, 0 times anything is 0. And 0 take away 3 is -3. -3 does equal -3. This is a true equation. That means this point is on this line. Or in other words, this point is a solution to this line. Number 4, we test that. We plug it in. Put the y where the y goes. Put the x where the x goes. Simplify. 1/2 of 4 is 2. 2 take away 3 is not 8. So that's not a solution. The answer for number 11 were equations 2 and 3. Those points are solutions to that equation. Alright, so number 12 says, the tank had some water in it. Below are the measurements. Write the equation to show the depth of water. Alright, so this is a, I guess I'm having you assume that this is a linear function. I should have said that, but that's all we're studying right now, so hopefully you just understood that. So this equation here, now, we see a pattern. Actually, it's proven by the table there. You see a pattern. They go up by the same amount every single time. The water raises by 5/10 of a centimeter every single time. In other words, the rate of change is constant. So that just proved that it's a line right there. So if we work backwards, we go all the way to 0. Okay. So if I'm going back 5 every time and I go all the way up to 0, I can the one before this would be 25. So at day 0 or at the start of this, it would be 25 centimeters. And the reason I need that is because if I want to write an equation for a line, I need two things. I need the slope, which is 1/2, because it's going up 1/2 or 0.5 every time. And I need my starting point, or I need to know when x is 0, what's y. So that's how we get the equation. 14, they give us a line and they say, what's the equation? Well, I can see the line intersects right here at 1, so that's y equals something x plus 1. and then I rise up 1, 2, 3, and I run over 1, 2, 3, 4. If I rise up, whoops, I'm sorry, I didn't go up high enough. If I rise up 1, 2, 3, 4, and go over 1, 2, 3, 4, 5. So that one point right there, well, I made a mistake. If you make the same mistake, let me tell you why it doesn't work. It looked like that line went through that lattice right there, but it doesn't. So you actually have to rise up 4 and go over 5, not up 3 and over 4. So the slope was 4/5. That goes in front of x. The line hits the y-axis right at 1, so that's what goes as the constant. There's your equation, y equals 4/5 x plus 1. 14 says, select whether the statement is true or false. For all cases, some cases, or never. All right, and the statement was this. When lines have the same y-intercept, then they intersect at only one point. So if they have the same y-intercept, they hit the y-axis at the same spot, then is it always true, sometimes true, or never true that they intersect in one point? So let's take a look at that. Here's an example of two lines that share the same y-intercept, and they only intersect one time. However, I could have a line that intersects through this, and then a separate line with a different equation that simplifies down to the same equation and also goes through that point, and it's actually the same line, which would have infinitely many solutions, which means this is only true sometimes, not all the time. Okay? Number 15. What is the x-coordinate of the solution to this system of equations? So here's our system. We're going to take one of these equations and isolate the variable. We want to isolate the one that has no coefficient. So I'm going to take this y right here and isolate that. So I'm going to move the negative 3x. And since I'm moving something, that's when I do the inverse operation, right? So if it's negative 3x, I add 3x. And then I see that this equation is the same as y equals 3x minus 1. This is the same line. Now, I'm going to take this and substitute it, this is why it's called the substitution method, into the other equation where the y is, because it says y equals. So, I'm going to take this equation and rewrite it. So, this equation is right down here. But instead of putting y, since y equals all this, I put all of this right there where the y was in parentheses. And we said earlier, when we solve equations, we do the rule for subtraction, distribute right here. 4 times 3x is 12x. 4 times negative 3 is negative 12. And pause this video right now and make sure you're doing these steps yourself and getting what I have. Then I combine like terms and isolate the variable, working farthest away from the variable first, doing inverse operations. And I see that x equals 2. Okay? Now, for this problem here, they wanted us to find the x-coordinate. Normally we'd have to plug this number back in here and get the y also and get the set of coordinates. But since it's only asking us what's x, I can stop because I found x, so I'm done. X is 2. Now, sometimes we find the y and we choose that answer. Make sure you pick the right letter on that one. Be careful. Make sure you're attending to precision, right? So number 16 says this. Select the statement that correctly describes the solution to this system. So we're going to solve this. Again, substitution method. This y is already isolated, so I'm going to plug this into the other equation right where the y is. I'm going to rewrite this equation. See the 3x, see the plus, see the 2, see the equals 1, but instead of putting y, I put all this stuff because y is all this. It's all that. So now I'm going to distribute. 2 times 4x is 8x. 2 times negative 5 is negative 10. I should have did the rule for subtraction there. So sorry, add the opposite. Well, alright then. So I'm going to combine my like terms now. Again, remember, if I'm not moving something to the other side, if I'm just combining these like terms and they're already on the same side, I don't do inverse operations, right? I just do regular 3 plus regular 8 and get 11. Now I do inverse operations because I'm moving stuff to the other side. I'm moving stuff around. And I work farthest away from the variable. 11 divided by 11 is 1. So x is 1. Now I can plug that in right here to the one that has the y isolated. I put it right here where the x is. I'm going to use that one. And I put the one where the x goes and simplify this expression. And I see that the solution to this is 1, negative 1. So now let's go look at our answers. The choices are there are infinitely many solutions. Well, if I ended up getting having a problem when I substituted here, and I end up getting the same thing on both sides just like before, that would be infinitely many solutions. I'd have the same coefficient once both sides were simplified. No solution, same thing also, except for you'd have different constants. So I did get a solution for this, and I just check and make sure I picked the one that has 1, -1. Number 17 says, solve the system. So we're doing the same thing we did the last couple problems, right? Only this time both y's are isolated. So what do? Do the same thing I did before. I take this one and I plug it in where the y goes. Or take this one and plug it in where the y goes. In other words, if they're both in slope-intercept form, just put them equal to each other, right, without the y's. Now, both sides are simplified. I can see I don't have the same coefficient, so this isn't infinitely many solutions, so I got to solve it to see what my one solution is. So I do the root for subtraction, and I'm going to get my x's together. So when I move something, that's when I do opposite. So if it's positive x, I take away x, because that will make this x go away. 7x, take away x over here, because remember, you got to do it to both sides, right? I get 6x, work farthest away from the variable, so since it's -3, I add 3, and then my last step, I divide in the last step, and I see that x equals 1. I need to get y now. So I'll take either one of these, it doesn't matter, because y is isolated for both. So I'll take the first one, I plug 1 in here, 7 times 1 is 7, take away 4 is, take away 3 is 4. The solution, or in other words, where these two lines intersect each other, is at 1, 4. 18 says, Justice's MMA gym charges $250 a month. The Williams School of Combat only charges us $175 per month, but has a $375 initiation fee. Find the number of months it will take for them to cost the same. All right. Well, we don't know the number of months, so we're going to let x equal number of months. And when we want to know if they're the same, it's just like that last problem. We just set them equal to each other, right? That's when are they the same or break-even point question is. Now I made them the same. I made them equal to each other for how many x's, okay? But for the first MMA gym, it's $250 per month. That means per x or times x. That's where we got this from. The other one was $175 per month plus $375 initiation. That's a one-time deal, so that's why the $375 doesn't go next to the x and the $175 does. So we distribute combined like terms. That's already done. Both sides are simplified. I see I have different coefficients, so there's one answer. Let's find out what it is. Subtract 175x from both sides. I want to get my x's together first before I try to isolate. Now I can isolate, divide both sides, and 375 divided by 75 is 5. At 5 months, they will cost the same. Number 19 said provide the correct equation, domain, and range for the table. So let's get the equation, meaning I need to get the slope and y-intercept first. Well, the slope is y minus y over x minus x. Now, I can do right minus left to avoid negatives if it helps. As long as I do right minus left on the bottom, even if I did get a negative there on the bottom, I'd have to still keep the same order. I get a slope of 2.5. Now, my starting point is, well, if I take a look at this, I can do it the long way, but if I look at this and I count backwards, it's going backwards 250 each time, right? So if I go backwards another 250 at 0 or for no tickets, the cost would be 0. In other words, that's proportional. My equation is 2.5x. So y equals 2.5x. The only thing is they're not using x's and y's, right? They're using t's and c's. Okay? So x's is the first one, right? So that's t. Cost is the second one. Okay, so that's c. So my equation would look like this, right? It would be c equals 2.5t. It couldn't be t equals 2.5c. Because remember, the x goes next to the coefficient. Excuse me, the x, yeah, that's right, I said that right. The x goes next to the coefficient, so you got to make sure whichever one would be the x, or the first one, the t, goes next to that slope and not the other one. Alright, now, so if we're looking at the table that they gave us, the x is over here, the first one is domain, and then in range. It's alphabetical order too, right? Domain, range, dr. So all you got to do is the only one that has the right equation is, it looks like B and D. So now you have to look at the domain and range. So here's the domain, 1, 2, 3, 4, 5. D has the right domain, B doesn't, so the answer has to be D. 20 says the car travels at a rate of 53 4/3 miles with 2 1/7 gallons of gas. At that rate, how far can your car travel on 1 gallon? In other words, find the unit rate. So how do we find unit rate? We go top divided by bottom. That's how it'll tell us how much per gallon then. So what I do then is I put this over this, which is the same as this, divided by this. How do we divide mixed numbers and fractions? Well, we make everything into a fraction first. So we make everything into a fraction here. 53 4/7. I go 7 times 53, then plus 4 to get 375 over 7. Those are the same numbers. 2 1/7. I go 7 times 1 plus 1. Right? I start from my bottom, work my way up. 2 1/7 is the same number as 15/7. How do I divide fractions? I multiply by the reciprocal. I keep, change, flip. You guys remember that? How do I multiply fractions? We learned this at the beginning of the year. We relearn this. We do our factor trees and cross out our ones. So 375, I do my prime factorization over here. I say, what goes into 375? 5. 5 times what? 75, right? And I just keep breaking it down, right? That part's review. So let's take a look at that. 375 over 7. Well, 375 is the same as saying 3 times 5 times 5 times 5 over 7 times 7. 7's already prime. Over 15. 15 is not prime. 15 is 3 times 5. Now it's prime. Right? Because 3 times 5 is 15. I cross out my ones. There's a 3 on top and a 3 on the bottom. I cross it out. 5 on top, 5 on the bottom. Cross it out. 7 on top, 7 on the bottom. Cross it out. Whatever remains gets multiplied. I have 5 times 5 on the top. 5 times 5 is 25. 25 over 1 is just 25. And that means 25 miles. Alright, hope that helped.